Okay, it's any moment now.
Got it.
Yeah. Hello and hey there, everybody. If you're like most folks, especially us, people in the world love the outer space stuff, and the universe is out there expanding and totally fascinating and doggone it of all the sciences. I got to tell you, folks, astrophysics makes more news than anything else these days. We try to flesh it out here on the SBAU Astro Hour, our weekly vlog podcast for the Santa Barbara Astronomical Unit, our longtime South Coast Telescope and Astronomy Club. My name's Ron Heron, radio guy who is vice president. This is episode 104 for the 20th of February through the 26th. This week, we're going to talk about the planets, where they are, all of them. Introduce you to a nebulous shape like a comma called a tadpole. And we might learn about intermediate black holes. Believe it or not, they're all dangerous, but these are the ones in the middle somehow. There's a nebula out there called Serenity, spotted by Hubble in a neighboring galaxy. How about the Horsehead and the Flame Nebulas and Planetary One and Cygnus? The Swan snowing on Saturn's moon Enceladus, and guess what Perseverance is digging up on Mars? Let's meet the gang. Mr. President in white, Jerry Wilson, 6 years now.
Pardon?
You're either doing a great job or nobody wants to do the responsibility.
I think it's more B than A.
Jerry Wilson is married to one of the two Pats. Pat Forgy is your wife. Is she home today? Are you guys? Are they listening?
No,
right?
She's out hiking with her.
Oh,
hiking
bless her heart. Well, I saw your house in that December talk you gave, and you're right out. Oh my God, there's a cat about to eat. Chuck McPartland, our outreach coordinator.
Morning.
His wife is also Pat, our merchandise manager. She may be home. What's the cat's name?
Shadow.
And I understand you are allergic to shadow.
A little bit. Yeah. My eyes water and my nose sneezes and things like that.
I had an Angora for about 2 weeks and had to turn it back because it would get on my shoulder. And I thought I had COVID. I really did. Hey, Tom Whittemore is here.
Morning.
Morning. Red. SBAU newsletter is about to be edited and sent out within the next week and a half. Former Westmont College science instructor. And I just learned earlier, we were chatting, you also had some term out there at the university, right?
Yeah, when we first moved here, they made me important. They made me a visiting assistant professor for a couple of terms. This is where they have, they don't have semesters, Chuck. They have what?
Quarters.
Quarters, yeah. For a couple of quarters, I was that. And that's how I met Chrissy Cook. And she was in the creative studies department. You know, like I said before, it's quite a feather in her cap. And I signed off on her thesis because I could. Okay.
Well, since you just retired from Westmont College, which is
3 years.
How many years?
It's 3 now. Yeah.
Okay. 3 years ago, you had a great little lab. You ever wondered, as I have, why there isn't a minister somewhere on stage that comes out Sunday and talks about God's latest discoveries in the Cygnus one and black holes? That's all God's work, but you never hear it. They instead go back. It's all Bible stuff.
Yeah.
It gets embarrassing when somebody starts asking for facts.
Yeah, that's Chuck, you want to give us a quick outline of outreach coming up maybe in the next week or two?
Well, we have Elwood School this week, but I'm afraid that's going to be during the rainstorm. It looks like we got a pretty good set coming on. And then the last thing we have for the month is on Tuesday, the 28th, is Telescope Tuesday at Camino Real Marketplace.
Okay. Doing those again. That's great. That was shelved for about 2 years, wasn't it, due to the COVID pandemic?
We also have, Goleta Valley Junior High on the 27th on Monday night. Forgot about that.
You're also getting some cancellations, but you send out the word. You're really good on letting us all know.
Yeah. Well, the cancellations were because I picked up a bug at one of the outreaches. We had like 4 outreaches in a row, so I don't know who to blame, but I picked up a bug and I had to cancel 2 of the schools. One of them kind of, 2 days ahead of time.
Well, do you happen to know, anybody know what happened to Bruce, our fifth picture, our talking head that's not with us? This Bruce Murdoch may be joining us. You never know. He doesn't have another bug, we hope. We do have some silly science cartoons that get forwarded to us by our very humorous president, Jerry Wilson's sense of humor. And here they come. We'll try to, this is the crashed weather balloon? I don't think so. Naturally, the guy says there was a bit of skepticism among the media regarding the official Air Force explanation. It's just a weather balloon. Yeah, there you go. With a couple of nonplussed aliens looking out. What is the difference between capella and a cappella? Apparently, you take away the instruments, right?
That's pretty good, Jerry.
A little Italian for you. The drum. Are there asterisms or constellations called the drum, the harp, the oboe?
You can make them your own. No, but you can make them your own, Ron.
That's true, but we're going to talk about a comet nebula, a comma shaped, and I think all the paragraphs are all the. Never mind, sir. It's the War of the Worlds versus Planet of the Apes. The monkeys we sent into space back in 1959. He says they're back. They've had it. But I learned we got them all back. What is this? Can you enlarge that poor guy in a body cast? And guess what happened to him? Anyway, there I was, 40,000 feet in my own private balloon, not bothering anybody, when suddenly President Biden ordered, how much did they spend with those rockets? 2.5 million?
No, they're about 400,000 each.
400,000 each. All right, this welcome to New York State needs some explanation. To enter the state, you got to solve this math equation according to the big sign. 2x squared plus 7 divided by 3 equals 13. You solve for x. Somebody in the lead card. What?
Yeah.
It's 4.
Mm-hmm.
Is 4 the answer?
Yeah.
Yeah.
It's not a hard equation.
This isn't some classic unsolvable math problem that everybody's been
No.
figuring out.
No.
Well,
That's high school algebra at worst.
Well, the part that would be inside the parentheses is 39, right?
Yeah.
And then somehow you get 2x squared plus and 4. So 2 4s
2, 16. Yeah, so x squared 16, so x must be 4. That's right.
Easy. Algebra 1, I had no problem solving for x, but xy, algebra 2, and I got lost. But
I've heard a suggestion that for people who want to vote, you go up to the booth and they present you with a couple of problems, a simple math problem and a question about current events. And if you fail either one, the booth opens up again and it's empty.
Well, there's some talk about making people running for government posts, Congress take a test, especially if they get old, but I don't think the age thing.
So I guess Mr. Straub is turning around.
Yeah, that's right. And part of the state's new emphasis, it says on improving education, we're afraid you'll have to turn around, Mr. Straub. My God. Nobody can be allowed in. Humans, I love this one. The reply back from the aliens who've seen the design plaque on Voyager 1 and 2. Was it on both spacecraft or just one of them? They're way out there, but
At least.
Carl Sagan, I think, came up with this, didn't he?
Yeah.
Yep. Mm-hmm.
And something Stephen Hawking warned us about. Humans, please don't send us any more unsolicited nude pictures of you guys with instructions on how to get your house to your house. It's creepy. Sincerely, the aliens. I always wondered about that. But here we go. This is meanwhile at the South Pole. That's what happens. You're hanging there. What did you comment, Chuck? You said something about this in a return email, and it was.
I think I sent something totally unrelated.
Okay, so they actually got the guy somehow standing on his head down. Oh, this is the good one. The Institute of Unfinished Research has concluded that 6 out of 10 people, ... Unfortunately, it's unfinished. And Tim Crawford, who may be watching us, sent an email saying, this one I like a lot because it ... Okay, here's the battle of the cowboys versus the UFO aliens, battle of the prop guns. Zap versus bang. Oh, it's terribly lethal. Is that our buddy who retired, Larson?
No.
That's not
No,
our sun.
that's
I
not
think
a
this
sun.
is called Rubes.
Oh, okay. I wonder if he retired too, but look at that. All right. Fascinating stuff. I don't know where you get it, but rest, it's a weather balloon. All right. Going to talk about the planets, tadpole, and a bunch of a molecular cloud. I don't know if I've ever heard that term before. Maybe I have, but I assume it's a form of nebula. Mr. President, you want to kick us off on the tadpole, or you want to go to the planets?
Planets first.
Let's
Yep.
go up there and find out what we got them all nailed down. Can we see them all? And not Pluto. There's no way we can see Pluto.
You can see them all with the telescope, except some of them right now are conflicting with the sun.
Well, all right. You want to read it or just let everybody read it? You're going to have to leave it up there for a while.
If you
No,
guys don't
we-
mind, I can make a comment here, a comment about
Go
the planet.
ahead.
Yeah, so Jerry mentioned about Mercury, but what I would like to say is that you can get a sense of the inclination of the ecliptic now because of the positioning of Venus and Jupiter. If you look to the southwestern sky after sundown, you will see them heavily cranked up. So what you see now in the setting part of the sun is the ecliptic is highly cranked. On the other side, if you get up in the morning, the problem right now with Mercury, there's two. One of the problems is that Mercury rises about maybe 40 minutes ahead of the sun. So it's kind of lost in the light. Okay. But the other problem with Mercury is now because the inclination of the ecliptic at the setting sun is just the opposite at the rising sun. So it's very, very shallow. And so even though Mercury is moving away from the sun, it's not moving away from the horizon very well. So it's really tough to see. So that's my comment on the planets.
Well,
Okay.
Mercury and Saturn have something in common. They're both in superior conjunction. I'm reading that.
Yeah. Again, Saturn
that
is way too close, Ron. Saturn is awfully close to the sun. Obviously it's on the other side.
Okay,
You can't really see it. Mhm.
Well, it seems to me superior conjunction might be connoted to mean disappeared behind the sun, and there's a straight
Yep.
line between all three of us, wouldn't you think?
Yes.
Yeah. In the case of Saturn, that's for sure. In the case of Mercury, okay, it's tough because the ecliptic is canted very shallow right now.
Okay.
I couldn't get it. And usually we have a pretty good horizon here.
And coming up, Venus and Jupiter are going to be nice and close in the sky.
Yeah, that's right, Chuck. Yeah, you can see that on the march right now. You can really see it. Yeah. Mm-hmm.
Low, okay, in the west after sunset, but not in the morning.
No.
Okay.
Yeah.
And
Now, one of our members was complaining that there was, we didn't have a name for the moon, but we do. The moon does have a name. So I put that in here instead of just saying the moon. But its official name, it has several, but one of them, the one I like, is Cynthia.
Mm-hmm.
oh, is that what Cynthia is? I thought maybe it was in this. Never mind.
Okay.
And
So
as
down
for-
at the bottom, you'll notice I put Pluto, and since it's on a list of, so I had to include Pluto's dwarf planet number assignment. So that's a Pluto's official name nowadays.
Really? 13,
Yes,
43,
it's
40.
not as
Not very
who's that
romantic.
guy?
Not very romantic, huh?
Yeah. No,
That's like its
But it's better
asteroid
than-
number. When
Yeah.
you determine an orbit for something, you give it a number. And
Mhm.
way
Yeah.
back when they were trying to, when they were saying Pluto's just another Kuiper Belt object, they wanted to call it, I think it was either 30,000 Pluto or 50,000 Pluto, because it was a nice round number. And the IAU said, no, let's just keep it a major planet for now. So it wasn't until 2006 that they demoted it and they gave it this number. And so you can see, going from 30,000 and then 50,000 to suddenly 134,000, you can see how many asteroids we've been discovering and how much faster.
But now they've defined a dwarf planet, whether it be in the asteroid belt or the Kuiper, as a spherical. It's big enough, even though it's 300 or 400 miles across, to make a ball, right? It's not
Right.
a rock. So how many balls are out in the Kuiper belt that are similar to Pluto, and how many are in the asteroid belt? that are about the same size.
Just Ceres in the asteroid belt, but it's only half the radius of Pluto.
Really? And there's not a couple other round balls that are dwarf planets in the.
Well, you know, there's some that approach it.
They're roundish.
Yeah.
But there's a couple of other dwarfs out there in the Kuiper besides.
Yes.
Haumea and Maki and.
Do their orbits go inside Neptune's like Pluto does?
No.
That I don't know.
Okay.
Some of them are in a similar resonance with Pluto, but I don't think they come inside.
Well, Jerry, who named our moon Cynthia?
That's an old name.
Yeah. So is Diana. Also known as Diana, right?
Yeah, I think the Greek version is Cynthia, and the Roman version is Artemis or Diana.
Artemis. Oh, perfect name for the new NASA mission. Then interesting, Cynthia. And then lunar. That's what, Spanish? Luna.
Yeah. Goes through a lot of languages.
Did we miss any of those planets? Or are you going to talk to them?
No, we did all that were visible. This is tomorrow at 6:45 p.m.
Okay.
And it's there because you see the moon, and my planetarium software doesn't really reflect the phase that accurately. This is a light crescent. You can see one edge is a little lighter than the other. So that's
Wednesday, by the way.
Pardon?
Okay.
That's Wednesday, not tomorrow.
Oh, okay. What was the date I had on it?
The 22nd.
Yes, you're right. Okay, good. Thanks. And this is it's close to Jupiter, close to Venus, and it's close to Neptune, but you're not going to see this. This is very close to the horizon, and it takes a small telescope to see it, 6 inches or something. So Jupiter and Venus are getting closer together. And on March 1st.
There we go.
And they're super
March
bright.
1st,
so yeah, that should be pretty neat. But like the eyes of.
So this is a week and a half away.
Oh, we're not going to have any occulting here, right?
That's correct.
No occulting.
That's right.
Yeah, the color on Jupiter is deceptive. It should be kind of a white glow.
Okay, so Jupiter is going by the moon, above it, below it, or
this is Venus and Jupiter.
Venus and Jupiter, yeah.
Well, I understand that, but okay, the earlier picture is what I'm talking about.
It's close to full moon at this time.
Okay.
So it's in the other end of the sky.
Yeah.
Supposedly the James Webb is finding out all kinds of new stuff about Jupiter. We'll have to cover that some someday in the future, some Monday. Watching us on YouTube, we hope, gang. Or what are we looking at now, Mr. President?
What's that?
What are we looking at?
This is our galaxy's core, and this is a single frame from a movie that is 12 years long, but stop action, so you don't have to take 12 years to watch it. Of things moving around the core of our galaxy. And this is leading into the tadpole.
So this is possibly radio telescope images, right?
No.
No, you can see this with a telescope?
Might be infrared.
Yeah, it's infrared.
It's infrared.
Okay, so
let's see how I'm going to do this now. I'm going to stop share and then see if I can get.
Let me set it up for you. A comma-shaped molecular cloud near the center of the Milky Way could have its own little black hole, not the big Sagittarius A supermassive, which is the center, they say, of our galaxy. But it's the missing link, a middleweight, intermediate size, between what, solar mass size, 5 or 6 suns worth and billions of suns worth, somewhere in the middle. There's
this one I think was estimated to be about 100,000.
Okay, but you can get a black hole from something the size of the sun, can't you, if it collapses?
No.
Yes.
Well,
No,
you'd have to do something to collapse it.
Yeah.
Well, it does it on its own, doesn't it? It
No,
makes iron.
no,
Nope.
no. Sun doesn't have enough mass to make iron.
Right.
Not yet anyway. Okay.
No,
No,
not
it'll
yet.
never, Ron, it'll never make iron.
But you did have a picture, Mr. President, of a comma up there in space. It looked like a big molecular comma. So can you find
Yeah.
that?
Yeah, just a sec.
Trust us, friends. It's coming.
Do you see this?
Mhm.
We're going to
Okay,
make it move.
it is moving.
Okay, that's all right. Stop action or time lapse.
This is a picture that was taken over 12 years.
Yeah.
That's
And
time lapse.
right in here, things are orbiting nothing.
Except,
And when you see something orbiting nothing, that's screaming black hole.
Yeah.
So this is the discovery photo for the black hole, the big black hole, millions of solar masses at the center of our galaxy. But now let me go back.
Jerry, was that a Margaret Geller,
Yes,
John
go ahead.
Huckra? Was that Margaret Geller and John Huckra? Because they were fascinated by these crazy paths of stars.
Or Andrea Ghez at UCLA.
Right.
Yeah.
Or she. Mhm.
well, they got to be going split act really fast.
Yeah.
Yeah. Oh, yes, they are. Mhm.
But then they're probably many, many AUs away from it, I would think. There it is. There's the comma.
They're
Yeah.
30,000 light years away from us, Ron.
That's true. Okay.
That's a lot of AUs.
Quarter of the galaxy across, I think about, isn't it?
Mhm.
And this has its own black hole.
The
but
movie that you saw was with a black hole that's millions of masses. They've also found near the center, but not at the center, not in that. This is an artist rendering, but they see a tadpole shape, which is a torn apart star that got too close within the Roche limit of the black hole, which is drawn down here. And because they see this thing, they can tell the mass of the black hole. And this black hole is one of the very rare intermediate range mass black holes.
But what's making the tail? Is that the big supermassive sucking in stuff?
That's just the thing being ripped apart because it's too close to the black hole.
Yeah.
Okay, in a way, that's the same thing, but that's not part of the accretion disk.
You
No,
can see the
no,
accretion
no.
disk there. That's kind of reddish
the
stuff.
relic. That's the relic of this star's orbit.
Okay,
see,
but
there's two competing forces here. First of all, there's the star, and it's gravitationally held together. And when that's the only thing going on, it's a sphere. It's completely, what is it? Anyway, it's perfectly round sphere. And then when it gets too close to something, the something can exert its own gravitational force on the object, and it tidally disrupts it, like the moon slightly does that to our oceans, because the oceans are real fluid. It erases, it pulls up, so it competes with the Earth's gravitational field.
Right. Here,
the gravitational field that's competing with the star's own hold me together field is way too strong. And so these different parts of it are being dominated by the orbital force they want to be in, or the orbital path they want to be in due to this black hole. And that's what's causing this thing to come apart. Now, there was a theory that was back in the 60s when everybody was jumping around thinking that California was going to fall into the ocean because of an alignment of planets, that external gravitational forces cause earthquakes, just like the moon raises water tides. It also can raise very slight land tides, and these would like trigger earthquakes and stuff. And the correlation was studied quite a bit, but there was nothing to it.
Really?
So, except in conspiracy theories, and I probably resurrected one right there.
Well, let me add to it that terrible tragedy in Turkey and Syria, that couldn't be related to global warming in any way. So maybe it's back to what you were talking about.
That's just
Yeah,
tectonic.
see, it's not true.
Just that we were ready for it. Now, here's the thing about this. This is not a nebula. These aren't a bunch of stars. This is one star with what around it? Just molecules? It's
Star
called a
material.
cloud. What?
Yeah.
Star material, and nebula just means cloud. So yeah, that's a nebula.
Yeah,
Oh, it
this
is a
a
nebula.
plasma.
But there's
Plasma
only
cloud.
there's only one star in it, and it's in the form of a black hole.
No,
No,
going
that's the
around a black
star
hole.
on the left, and the black hole is the little orangey looking thing on the right.
Oh, okay. So it's a nebula with what, hundreds, thousands, just a handful of stars?
No, no, it's
no,
one
no.
star. It's one star being torn apart by the black hole.
right.
Oh, so it's a binary.
Well,
And then
it's sort of. It's not like I don't think it's in a permanent orbit here.
what's all the white stuff?
That's stuff
Stellar
that's been
material.
dragged off the star.
Yeah,
Okay.
that's
and
the
it's-
star being ripped apart. So the total mass of this black hole is about 100,000 solar masses, whereas the one at our galactic center, indicated by that movie, is several million, I think 3 million times.
4.3 million, I think, last count.
Okay, good.
Okay.
100,000 of our suns crammed together, and that makes an intermediate.
Right
Yeah.
there. Yeah, that's just the little guy.
It's all relative.
You can make black holes, and they do in the colliders.
Mhm.
And the smaller the black hole is, the shorter it lives. And the ones that are produced in collisions last incredibly short periods of time. So they have to be, I think, largely inferred that they're there.
Mhm.
Oh,
But I'm not going there. It's not my field. Now, from the inner reaches to the outer limits here, this is a representation of our galaxy. We have a
Okay.
number of, what's that?
No, I was just getting acclimated here, Jerry.
Okay. So you can see we're a little bit of a barred spiral in there. And this is what's called the Sagittarius stream. And so what the idea is that when you get two bodies orbiting each other, and you can tell the masses and the forces involved in it, the masses and the distribution of things. Having satellites and moons around planets, major planets, is how we can infer the composition inside by watching the detailed changes of the orbits of things. This is a small dwarf galaxy around our Milky Way that is being tidally ripped apart, very similar to the tadpole being ripped apart, but much closer to a black hole. Here, and so over a period of time, billions of years, it's leaving this trail of stars, which can be seen. And so we don't have to wait to watch something orbit our galaxy. The orbit here is mapped out by leaving all these breadcrumbs behind for us to see. So the trail is left there. And from that, they infer the distribution of dark matter in our galaxy. And that's called the Sagittarius stream.
Dark
go ahead.
matter has something in common with black holes.
Only that it's mass. That is, black holes were causing that star to come apart, but black holes are not causing this Sagittarius stream to come apart. That's just the gravitational pull of the galaxy.
Well, correct.
It's
Forgive me if I'm wrong, but the center of our galaxy, the black hole, is called Sagittarius, and this little orbiting
right there.
satellite galaxy is called
Run. The black hole is called Sagittarius A star.
Mhm.
This is called the Sagittarius dwarf galaxy. That's because from our point of view, they appear in the part of the sky that's covered by the constellation Sagittarius.
Always.
Yeah.
Constantly.
Well, I mean, eventually this thing is orbiting. It'll move out of there, but not in our lifetime.
Yeah.
Okay.
You're being led astray by a similarity of names.
But
Coincidental.
there's no way you guys can train your telescopes at this and see that circular trail or that
The
ring.
problem with this trail is that you have to see it through a very dense part of our Milky Way. So you have to get rid of all the foreground stars. That's one of the difficulties in finding these dwarf galaxies. They're so beaten up and ripped apart by proximity to our galaxy that it's just this almost cluster of stars. It looks like a star cluster. But you can, and they're mixed up with the Milky Way stars that you have to see through to get this. So they're not clearly visible in most cases up there. Now, we do have a number, let me just go back here and show you that we have around us in the Milky Way here, we have the Sagittarius dwarf galaxy, which is right here. And what that previous picture showed was the streams, the trail that are mapped out by it. But we have these other dwarf galaxy remnants, Ursa Major 1, Ursa Minor dwarf, Draco dwarf, Sextans dwarf, and they're named for the constellation we have to look through to see them. The Carina dwarf, the large and small Magellanic Clouds, the Sculptor dwarf, and I think I covered all of them, Ursa Major too. So the really big ones, the only easy ones to see with your naked eye, are the large and small Magellanic Clouds, which you can see from south of the equator. And this is from a picture taken at an observatory in Chile. This shows the large Magellanic Cloud and the small Magellanic Cloud. So these are the remnants of dwarf galaxies that orbit the Milky Way.
And the way you find the really faint ones is with the spacecraft now like Gaia that are measuring the proper motion of stars. What you see is a group of stars that are traveling together the same way, even though they're embedded in another big group of stars in the foreground. So if you have the distances and or the proper motions, you can sort them apart by where they are and common characteristics.
Is our Milky Way sucking them in over time?
Yes.
Mm-hmm.
But the Andromeda is way out past this local group, right? The local group is just us and our satellite galaxy.
Well, no, the local group includes Andromeda.
Oh, it does. Well, why aren't some of them orbiting Andromeda?
There are some.
Oh,
Yeah, Andromeda has its own dwarf galaxies. Now, here's this clump of the Sagittarius dwarf, and the gravitational pull of our galaxy is pulling this object right straight there. But it's also got a transverse velocity that this thing can't really affect. Well, it can. But so by the time this ball of stars gets to this distance, it's moved to the side, so it's really over here, and that's what defines an orbit. So it's being pulled in, but because it's got this sideways motion, it can't make the corner. So it's got to decay away, give up its energy before it can completely spiral in.
what are those smaller inner rings that don't seem to be in our ecliptic, our galaxy?
Those are trails that other galaxies, I guess, because it looks like.
Well, those may also be previous, passes of this Sagittarius.
Right.
Wow.
And it's not an ecliptic, Ron, but yeah, the plane of the galaxy.
Yeah.
You're right.
Ecliptic is a very specific term.
It's a solar thing. Okay, I got it.
Yeah,
So
our ecliptic's about 60 degrees from the plane of this galaxy.
All spiral galaxies have a plane. Elliptical galaxies don't. They're just a ball of cotton, aren't they?
Right.
And
Now,
are we looking at something that is similar to the phenomenon that produced the rings of Saturn, you suppose? Why wouldn't that ball, that clump, that just scatter out and become a ring around our galaxy?
It's gravitational. Yeah, it's in some respects it's related.
Okay. And then we're finding all kinds of bodies out there with rings.
Yeah.
Yeah.
They can
This is the large.
Okay.
This is the large Magellanic Cloud.
Named for Magellan.
Named for Magellan. He first saw them in the sky. He was the first English explorer with a ship and a diary to see them. People in the southern hemisphere Polynesians navigated using them all the time. But there's a lot of stuff in it, like you'd expect in another galaxy. All these nebula regions. This is the Tarantula Nebula, big thing. There's the Gum Nebula. I'm not sure that's in here, but it could be. The reproduction is not easy enough or clear enough for me to see the names there. But you get the idea. There's a lot of star clusters. There's a lot of nebula. There's a lot of star forming regions, a lot of planetaries.
It's even got a barred core.
Yes.
So would it be fair to say that all those galaxies, those dwarf galaxies that are orbiting us, are not mini revolving spirals? They're mini ellipticals, right?
Sort of.
No.
This one has more of a barred spiral shape to it.
Yeah. Most of the spiral arms have been ripped off of these things. What you see is the core. This one is early in its being ripped off stage.
Yeah.
But the point of all this is this very dramatic
Wow.
Nebula?
Yeah, the nebula. It's the Serenity Nebula, I think.
Whittemore, what were you saying?
Yeah, the Serenity Nebula.
Okay.
This is somewhere in the Large Magellanic Cloud.
Oh, really?
Yeah.
You can see that clear in another galaxy.
Now it's really interesting to me because, and not to spark any more conspiracy theories, but it looks like a piece of fabric that's been ripped apart and sewn back together by a Boy Scout just learning how to sew.
Yeah, it does.
So it's a very interesting galaxy. The red stuff is stuff that's excited by neighboring hot stars, and so it's glowing by its own emission, hydrogen. The blue stuff is shining by reflected light.
What about the yellow?
What about what?
Well, I mean, can they tell by these colors what, aren't they made of different elements, perhaps?
Yes. Which
Oxygen?
elements are fluorescing?
Okay.
Yeah.
But now, is this a star forming region we're looking at?
Yes, it is.
Yeah.
When it gets that dense, it's forming stars.
Yeah. So Ron, keep in mind that, this galaxy's in the ballpark of 100,000 or so light years away from us, whereas, Andromeda is, 2.5 million. So it's pretty close, as galaxies go.
They're orbiting us mostly, but
they're being dragged in by us.
all things orbit each other.
Yes.
But the big guy wins. It's the
our galaxy supposedly, we're smaller than Andromeda, I believe. They're about twice as high a radius, perhaps.
Now, someone on the internet the other day asked if we could accelerate the Earth to half the speed of light. And that's a nonsense question, because you can't tell speed. Absolutely. You can only tell acceleration. So speed is only relative. So if there is an object, a solid object other than light, anywhere in the universe that is moving at half the speed of light, which I think there probably is, then with respect to that object, the Earth is moving at half the speed of light. So this is what it feels like to be moving at half the speed of light. It's just simply nonsense.
That would be 93,000 miles a second.
Yeah.
Wow.
And a lot of that is just because the space is expanding between the two objects. It's not like they're traveling through their local space at that velocity.
Yeah.
Well, because of that, we'll probably never get the light from the really distant galaxies over 13, 14 billion miles away, will we?
It'll be longer than that.
Longer what?
Than never.
Yeah.
Oh,
Well, we're seeing, 13.5 billion light years in the past already with James Webb. So
yeah.
Yeah.
And
just a quick comment, you guys, there was an absolutely fabulous little article in New York Times last Tuesday of an image taken by the James Webb of a galaxy that's about 1 billion light years away from us, and it looks like us. It just looks like us. It was a Dennis Overby, just a little splash article in the Times. Highly recommend if you find it. It was last Tuesday, Science Times. It's really good. It's a really good little thing.
And
the image is phenomenal. The image is amazing.
And Ron, just, some people get confused because you will hear different ways of talking about the distance as far as the size of the universe. And one of them is called look back time. And that's when you're saying, this is how far away that object was when it emitted that light. Okay, so and that's the 13.8 billion that we're talking about here. But you'll also hear people saying, oh, but the universe is 46 billion light years in radius. And that's what's called co-moving time. And that's where those objects that were 13.8 billion light years away when they emitted the light, the expansion of space has now taken them out to 46 billion light years away. Okay, so that's why you'll sometimes see the confusion. People say, well, wait a minute, I heard the universe is 46 billion light years in radius, and other people say, no, it's only 13.8. It's two different ways of looking at the distance.
But we are reaching the barrier for optical, right? It's
and that's the 13.8.
Yeah, and it's gone to red, which is the low end of the light scale. Why wouldn't they be aiming radio telescopes? Because that's even below.
Well, they are, Ron. That's how they discovered the cosmic microwave background.
Yeah,
radio
microwaves. It's gone red to microwaves.
The surface of the fireball of the Big Bang has been redshifted into microwave frequencies.
Right, and that's about a centimeter in wavelength, Ron, just roughly.
So we're not really seeing red. We're just seeing a radio blip that they color red. Is that what you're saying? It's not.
Well, it's redder. I mean,
redder.
Longer wavelengths are redder.
Right, shifted towards the red.
Okay, but
not red, not little red dots.
Yeah.
But we reached it.
Microwaves past red.
Okay, got it. President, take over again, please, sir. I keep learning. What is this?
This is a born again planetary nebula located around, actually it's the star that's born again, located around 5,000 light years away.
It found Jesus.
Yeah. In the constellation of Cygnus, so you won't be able to see this tonight. It's called Abel 78, and it's an unusual type of planetary nebula. It has gone through the first stage, like our sun will, where fusion stopped in the core and it off its outer layers. Let's see, and
so all that blue has been blown off the star.
Yeah, it was been blown off, but a lot of it is falling back on the star, and it's starting hydrogen fusion on its surface, but not in the core.
That's why you said born again.
Okay. Yeah, and that's when it's
okay. I got you.
When
and so this is like a nova.
Yeah.
A supernova? You mean an explosion?
Not a supernova. A nova.
No, just a brief flare up.
Yeah.
But now that's a single star. It's not a binary, right? It's not something sucking the matter off its companion.
It has a source. It has a source of hydrogen to call on to recoat its surface with hydrogen, and when that builds up dense enough, then it causes a fusion reaction again, a thermonuclear reaction that causes it to burp off its layer again, and this can repeat over and over.
And that may be because it has a companion that it's siphoning material off of, or just because when it burps, it's not quite energetic to overcome the gravitational attraction of the white dwarf, and some of that stuff falls back down.
Well, I know you've explained this to me before, gentlemen, but the word planetary nebula, there's a reason for it, and I kept thinking, well, maybe the blue stuff is going to turn into planets, or
no.
Okay.
The reason is, when these were first being studied, they could see the green, the fluorescent green from oxygen, because your eye's more sensitive to green.
Right.
So there were these greenish blobs, and it was shortly after they had found Uranus and Neptune, which looked like greenish blobs. So they said, okay, these are clouds that look like planets, planetary nebulae.
Okay, I see.
And in the optical telescopes of the day, they presented very small discs. Some of them were round, and but a few seconds of an arc across, just like planets like Neptune and Uranus would present.
And when they took the spectra, they could see that there was this weird single line emission stuff going on, and they knew it wasn't a star, but they didn't know that was oxygen emission. And it wasn't until like the 1920s that they figured that out. So they were calling it nebulium, the material that was emitting the light.
Nebulium.
Yeah. Yeah. So twice ionized oxygen gives a nice green line. You know, it's called oxygen 3, unfortunately, even though it's twice ionized.
That's those chemists.
Yeah.
But our solar system, the stuff we're made of, gentlemen, came from something like that came out of a star, but usually one that's blown apart totally, right?
Yep.
Mm-hmm.
This one may relive again.
We're made out of star barf.
Yeah, we're about the third barf.
Yeah.
So this is obviously one of the most recognizable constellations in the sky, Orion.
Yep.
And Chuck was last Friday at Westmont College with his video setup, and they were looking here at M42, the Great Nebula in Orion. We're going to look over here at near star Alnitak, because there's a lot of nebulosity in the region, and there's also nebulosity here. They're both hydrogen emission, and so they lend themselves very well to amateur. Okay, can you guys hear me okay? Because I just got a note my internet connection's unstable, so I may disappear. If I pop away or freeze, you'll have to take over. So anyway, hydrogen alpha light.
Is the horse head in there somewhere? There it is.
This is the horse head right here.
Right.
And this over here is the Flame Nebula. And this was taken with a hydrogen alpha filter. So it's a very dim light, but it does not interfere with your, that is, there's no, you can take this picture from the city because there's not much hydrogen emission light in the city. And so, I mean, from artificial lighting. And so you can, on nights that it's very poor bright sky, you can still get images like this through narrow band imaging. It takes a long time to build it up, but it's very dramatic. And there's a lot of structure in these things. The Orion Nebula, including this one near the star Alnitak, I think that's Alnitak.
Yeah.
And so there are regions in here that are dense enough to start forming stars. They're called Bok globules. These dark regions here, they form and collapse and become dense enough to obscure the light. We also have in this region, we have
the witch head.
This one, this blue region down here is this. So this is called the Witch's Head Nebula. It looks like the chin, nose, eyes, profile of a witch.
And your little dog too.
Yeah, well, a little dog or something's up here. So anyway, these are very rich regions. You can see the faint red coming through. The one that's from hydrogen alpha, when this gets colorized, the person will make all this red too.
And Ron, these are the molecular complexes. Okay, these clouds of gas and dust.
They're not dust. They're not little particles.
Well, yes.
No, they are.
Yes, there's both in
there. They are too.
There's dust and there's gas.
How does doesn't dust require something solidifying into a planet and blowing up later?
No. Carbon stars like Betelgeuse, when their outer layers are cool enough, they can actually form carbon molecules that then get blown off and accrete into dust.
Spectral lines characteristic of molecular water are frequently seen in novas. So it produces copious amounts of water.
Well, elements tend to combine and become molecules more than staying by themselves as just an element, right? Maybe with a few exceptions. There's more hydrogen.
If they can find the other molecule to bond with.
The other atom.
Oh, there's a nice Bok globule.
You suppose oxygen stays at O2, our breathable version out there?
No, it's very reactive.
Yeah.
What does that mean?
It wants to join other things.
Oh, I see. Yeah.
Like CO2.
Okay, right.
There's
Okay.
lots of CO2 around, not
But
much
it does-
oxygen.
But can O just stay O1 by itself, or does
It
it?
doesn't
no.
like to.
No, we've got oceans full of O that didn't stay O, and Mars is covered with O that didn't stay O. It's Fe2O3.
Mhm.
And if it gets enough hydrogen, there's probably water everywhere in there.
Yep.
Yep,
Whoa.
we have the rings of Saturn, we have asteroids and comets. Everything's loaded with water.
You suppose
The
it's
moon even has water on it, although it's bound in minerals. This is, as Chuck points out, a Bach globule. These are little bits of the dust and nebula that have gravitationally combined, attracted each other, and they become dense enough to see through them. And they're eventually going to become stars or multiple stars. This big one in the foreground will probably be multiple stars. And then stuff that doesn't get incorporated in the main body will become planetary disks. So this is a star in the womb, you might say.
It looks like a paramecium or something.
It's a caterpillar and it's getting ready to form its chrysalis and become a butterfly star.
There you go. That's what I was looking for. Wow.
I don't know. To me, it looks like a tardigrade.
Yeah, yeah.
Well, I think I saw all that stuff you just showed us in Orion on Chuck's laptop screen connected to his telescope, and it was all pink, wasn't it?
Yeah. There's
Okay.
some bluish and darker colors in there from the dust, but the pink is fluorescing hydrogen.
Mhm.
That's how it comes to you. It's not fake. Where are we on Mars now?
Mhm.
No,
Or Enceladus? Oh, this is Enceladus.
Yeah.
This
yeah,
is the moon.
this is snow day on Enceladus.
We're
Enceladus
dreaming.
has these geysers on one end of it that throw out all this ice and water from a sea underneath, saltwater sea. And a lot of that ice joins the rings of Saturn and produces its own ring. But a lot of it also falls back on Enceladus in these very, very deep snowdrifts and snow piles. And so this is a close-up examination of one area of Enceladus that shows its deep snow. So they're trying to estimate how fluffy this stuff is, how deep it is, because plans in the future are to try and land on Enceladus, and it may be deep powder, and so you're just visitors.
And that was like 700 meters of deep powder, right?
Yeah, estimated,
Wow.
yes.
Well, there's a lot of ice planets out there. Are they all snowing?
Could be.
I
You need
think
to have the
a lot of them-
gravitational squeezing, I think.
Yeah, this one is close enough to Saturn that Saturn has land tides. And so it squeezes, it basically pumps the planetary body, and that causes fissures to open up and it to squeeze some of the water in the seas underground to come out as geysers. And that's where the snow comes from. A lot of things are ice, but they're all solid ice.
Well, it occurred to me, gentlemen, that water has been considered three forms. It's either liquid, ice, or steam. But snowflakes is kind of a fourth form, wouldn't you say?
Well,
ice.
That's solid.
It's ice, but
Fluffy
just
stuff.
ice that's not in
It's
one
crystal.
crystal.
It crystallizes in six-sided forms for some reason. No
You
two
can get
alike. Yep.
You can get single crystals of other elements too and other compounds.
Oh, you can.
Yeah.
Okay, so how do they intend to land there?
I don't know how they intend to do it. I think they're still asking themselves that question. How the hell are we going to land there?
Big snowshoes.
Well,
So I read a science fiction story when I was a kid, a short story. I subscribed to a science fiction magazine called Analog. And one of the stories in there talked about the very first manned mission to Pluto. Pluto was still a planet then. But Pluto was so far out there that it had everything, all the elements on it for an atmosphere were all frozen into piles of snow and stuff. So it had nitrogen and hydrogen and oxygen and all these things you know, just frozen in vast mountains. And the spaceship did the Starship, or the Starship landing technique. It turned around and it lowered itself on its rocket. And as soon as it turned on its retro rockets, the entire planet blew up, because all the oxygen and hydrogen all of a sudden this was the first flame to come to the planet ever. And all that unreacted gas just went off.
That was before George Lucas gave us the Death Star, but it sounds pretty close. Well, you know, they could land with the hottest thing they want with a flame, and as long as it's like a submarine, and then just let it sink down into the ocean below, and have a way of sending the radio.
I think you got to get to the ocean below. It's not just snow on top of the water. There's solid crust on top of water. You got to figure out a way to dig through the rock.
Rock is above the water, which
or ice in this case, more like
ice. Yeah.
Oh,
the plan back in the 90s, when we were just think about the non-existent and non-funded JIMO operation, was to land a nuclear reactor on Europa, which has a sea underneath of its ice, and the reactor would just be hot, and it would slowly melt its way through the ice into the ocean underneath. So
and you lay out an antenna behind you so you can still talk to it.
Sure.
Right.
Well, you say slowly, it might be very quick too.
Depends how hot it is.
Well, it's 20 kilometers of ice probably, so.
Yeah. My understanding is life on Earth would not have ever happened if ice did not get lighter when it solidifies and become ice on top. If it was the opposite, we couldn't have had fish and down in the bottom of the water, you know.
That would survive winters.
That would survive
well,
anything.
I think life would have adapted to whatever we had.
Yeah.
You think so?
Yeah, you certainly have microbial life, you know, frozen in tundra and ice situations in Antarctica that you know, that kind of stuff would survive.
I know, but they had to get there, and they do it by sitting in little tidal pools with a strike of lightning, you know, and stuff like that. I don't know if we're going to have time, Mr. President, to talk about Mars.
Yeah, that's a lot of talking. We'll try that next week.
Okay. Is it worth discussing these new discoveries, or actually theories about dark matter having something to do with black holes?
We can discuss that as soon as I know enough about it to discuss it.
All right. Fantastic.
I've only read the headlines.
All right. So we're a week away from, his name is Raphael Cottam, and he's going to be talking to us live in the hall, Farrand Hall, where we meet on the night of the 3rd, which is next Friday, a week from this Friday. Incidentally, can I say this really before we go? Our great benefactor, the Natural History Museum up in Canyon there, is having a closet sale this coming weekend, Saturday and Sunday, the 24th or 25th and 26th, 10 a.m. to 5. It's free admission for shopping, and it's in Fleischman Auditorium. Come and check out books, possibly rocks, maybe some of Chuck's meteorites. You have yours for sale on the side of that. That's a yard sale for you, isn't it? If you ever so you're invited, and we'll do this again next week for number 105 as we start our 3rd year, man.
All right.
Maybe we'll have a full house and get Bruce back. Thank you, Tom. Thank you.
All right. Thank you, Ron.
And
thanks, guys.
And thank you, Mr. President. We'll see you on Monday, the 28th, 29th. No, 27th.
27th.
That's it. All right. Good luck to everybody.
Okay.
Stay warm.
All right.